Hello everyone, I'd like to welcome you to this video titled Real World Problems, Speed and Average Speed, and I want you to get out your math journal, turn to page 277 in your Math in Focus book, get out your calculator and also a pencil. So we can see the goal for this lesson is to solve real world problems involving speed and average speed. Now we're not going to look at every single skill within this lesson, we'll just look at a few. But the first thing we're going to take a look at was something that some of you may find helpful is draw and use diagrams to solve real world problems involving speed, distance, and time. So you can draw a diagram. So there are a few steps when you go to draw a diagram. So first of all, you need to understand the problem. Think about what you know, what you're trying to find. You also want to think of a plan. So you want to draw a diagram for your problem. And then you can see on page 288, carrying out the plan, and then checking your answer. Okay, so those are the steps that you'll want to think through as you're drawing a model. So you, once again, want to understand the problem, think about what you know, what you're trying to find. Think of a plan, and then from there, carry out the plan, carry out the model that you've drawn, and then also check your answers. So let's take a look at doing this on page 279. We'll go ahead and turn there in your books. So we can see, first of all, for this problem, that Miss Green started to drive at 7:50 a.m. to go to her office. She drove 30 kilometers at an average speed of 60 kilometers per hour. At what time did she reach her office? So we need to think about what we know. What are some of the things that we know? We know that she drove an average speed of 60 kilometers per hour. So let's write that in here at the top. So 60 kilometers per hour. We can see it right here. Also the distance, 30 kilometers. And also some things that we know is she started at 7:50 a.m. So 7:50 a.m. there. Okay, so what we're going to do is think about the time that it took her. And so in order to find the time taken, we take the distance and we divide it by the speed. So we think about the distance, 30 kilometers, divided by the speed, which is 60 kilometers per hour. Okay, so we can see 30 divided by 60. That's going to give you 0.5 or 1/2 of an hour. So we can see there that it's going to take her 30 minutes. Okay, so it's going to take her 30 minutes to drive to the office. Now, does that tell us the time that she reached her office? No, it does not. That just tells us how many minutes it took. How do we know that? We took the distance once again and divided it by the speed. Okay, so when you think about your diagram that you're drawing or your model, we're going to think about 7:50 a.m. and we need to convert this to make it use up 30 minutes here. Okay, we can see it took her 30 minutes. Now, what we can do is 7:50 a.m., 10 minutes to get to 8 a.m. Okay, and then from there we have another 20 minutes for a total of 10 and 20, which gives us 30, and that's going to put her at the office at 8:20 a.m. So she reached her office at 8:20 a.m. Hopefully work did not start at 8:15 or 8 o'clock. Hopefully it started maybe at around 8:30, something like that. So Miss Green arrived at her office at 8:20 a.m. So we're going to jump all the way over to page 283 and we're going to take a look at practice drawing and using diagrams to solve average speed problems involving a fixed distance. So we can look at this and it says Mr. Hughes took 4 hours to drive from town A to town B at an average speed of 50 kilometers per hour. So once again, we got to think about what we know, what we're trying to find. On his return journey from town B to town A, he traveled at an average speed of 80 kilometers per hour. How long did Mr. Hughes take on the return journey? Okay, so we're taking a look at a couple things that we know. We know the speed, okay, from town A, okay, to town B. We got to think about that. That's 50 kilometers per hour. How much time did it take? It took 4 hours. Okay, now what we know from town B, what we know is 80 kilometers per hour, but we don't know how much time it took there. Okay, and that's what we're trying to figure out. How long did it take Mr. Hughes to, how long did Mr. Hughes take on the return journey? So we got to think about that. So we know a couple things and we're trying to find a few things out. So we take the information that we have. So we know from town A to town B, 50 kilometers per hour multiplied by 4 hours. So it's a total of 200 kilometers there. Okay. So 50 times 4 equals 200. Now again, we need to think about time taken on the return journey. That's what we're trying to figure out. So we take the distance and we divide it by the speed. Okay, so we know that the distance is 200 kilometers. Why do we know that? Because 50 kilometers per hour for 4 hours gives us that 200. So we take the 200 and we divide it by the 80 kilometers per hour. And that's going to give us 2.5 hours. So we can see that Mr. Hughes took 2.5 hours on the return journey. So again, you got to use what you know to try to figure out what you don't know. So think about what you know within the problem and try to also figure out what you're trying to find. And then from there, understand that in order to find the time taken, you take the distance, 200 kilometers, divide it by whatever the speed would be, and that shows you how long something takes. So now let's flip over to page 285. This is going to be the last problem that we're going to look at here. So page 285, we're going to practice drawing and using diagrams to solve constant speed problems involving two objects or persons moving towards the same endpoint. We can see what that says right at the top of page 285. And so a couple things that we know, it says the diagram below shows the distance between Alexa's and Victoria's home from their offices. So we can see Alexa's office is 24 kilometers. Victoria's office is 48 kilometers. So that'll be something that we'll need to refer back to. Both of them drove from their offices to home at the same time. Alexa drove at a constant speed of 60 kilometers per hour. Victoria drove at a constant speed of 64 kilometers per hour. So we need to figure out who arrived home first. So we can see once again, we take the distance and divide it by the speed. So we can see Alexa drove at a constant speed of 60 kilometers per hour. So you take 24 and we divide that by 60. We're so used to division with always taking that larger number first and divide it by the smaller one, but understand we got to take the distance, whatever that is, and divide it by the speed. And that's going to give us 2/5 of an hour. And 2/5 of an hour is going to be 24 minutes. So that's how long it took Alexa to get home. Now let's take a look at Victoria. We take the distance, 48 kilometers. And we divide that by the speed, which is 64 kilometers per hour. And that's going to give us 3/4 of an hour, or you may get 0.75. And that's going to give us 45 minutes. Okay, that took Victoria. So we can see Alexa right away. Only took her 24 minutes. So Alexa, I want you to write that in, arrived home first. So we can see Alexa arrived home first. It took her 24 minutes compared to Victoria's 45 minutes. Now the other question, how many minutes later was it before the second person got home? We just take the 45 minutes that it took Victoria and subtract the 24 minutes that it took Alexa. We can see that equals 21. So from there we can see it was 21 minutes later before the second person got home or before Victoria got home. So this concludes the video on real world problems, speed and average speed, lesson 5.5 and module 5. If you have any questions about this concept, please come and see me.